Okay, Newton's method is pretty cool. This is a method we learn in calculus class that helps estimate roots of a function. And while you might think we only learn this because Newton himself is credited for the invention of calculus, that's a whole different discussion. But we can't fully appreciate the power of this method without a good understanding of equations of tangent lines. So what exactly is this method? Let's go ahead and explore. I want you to imagine a function that has some roots on the x-axis. This is a pretty easy function, so you can probably estimate what they are, but let's pretend we don't know them. We start by making an educated guess as to what we think the root will be. We'll call this x1, and in this case it's going to be about 4.5, which is kind of close to the root we're trying to find. You can draw a vertical line to find the y-coordinate corresponding to it. That's our f of x1. And here's where the calculus comes in. Let's go ahead and draw a tangent line. This tangent line is crossing at the point on the function where we can find the slope f prime of x1. Notice that this tangent line will eventually cross the x-axis. But more importantly, this particular x-intercept is even closer to the root than our original x1. We're going to go ahead and call this point x2, but let's figure out how we actually find that point. All right, so here's our x1, and as we mentioned, we can go ahead and draw a vertical line, and now we're going to be able to find our f of x1. I'm just going to go ahead and label this x1 comma f of x1. And like we mentioned, we can go ahead and draw a tangent line crossing through this point. So here's my tangent line. It might not be the best representation, but that's okay. And what we want to find is this particular point right here, which is going to be our x2, because that's the one touching our x-axis, and it gets closer to the root that we're trying to find. So now exploring some calculus, I'm going to write the equation for the tangent line. Y minus y1 is equal to m times x minus x1. Let's change a couple things up a little bit. So x1, we're just going to keep it like that. Our y1 is going to be our f of x1. Equals, and now our m, don't forget, that's the slope of the tangent line at that specific point. That's our f prime of x1. And so now I rewrite everything else. And because we're trying to find the x-intercept, in this case, our y is going to equal to 0. So we're really just left with negative f of x1 is equal to f prime of x1 times x minus x1. And in this case, we're trying to find the x value, which is going to be the x-intercepts. So let's go ahead and do a couple things. By dividing the f prime of x1 to the other side, we have negative f of x1 over f prime of x1 is equal to x minus x1. Now we're trying to find the x value. That's going to be our x2. And so now let's go ahead and add the x1 to the other side. Check this out. x1, minus f of x1 over f prime of x1 is going to equal to our x. And now we're going to go ahead and label this. Instead of x, we're going to say this is our x2. That's exactly what we were trying to find. You'll notice that this x2 is now the x2 in question. And this is exactly Newton's method. This is what Newton did in order to estimate the root of a function. And if you continue this multiple times, you will eventually get the root that we're looking for. So we found this x2. And from there, we followed the same process, and you're going to notice that we get even closer to the root that we want. From there, we continue repeating as many times as we possibly can, and we'll eventually arrive at a good approximation of our root. Pretty cool, isn't it? Okay, let's get our hands dirty on this now. So here we have an example of some random function that I created, and we want to find the root. Now you can already tell that it's going to be 1. I mean, that's pretty simple just looking at the graph. So I wanted to give us something that's somewhat easy to just visualize. But let's just say we didn't know this. So let's go ahead and estimate by making our x1 equal to 2 in this case. All right, so the GoodNotes app was not cooperating with me, so I'm just going to have to draw this function. And in this case, now we're going to have our x1, which is going to be 2. So if we draw a vertical line, again, it's not going to be the best picture, but let's just say it's somewhere here. And now the same thing follows that we're going to go ahead and draw our tangent line, and we're going to eventually get to something that's going to be our x2, and we're going to figure that out. So if you remember, in order to find our x2, it's x1 minus f of x1 over f prime of x2. Before we continue, I'm going to go ahead and find our f prime because we're going to need that. So we have our f of x. And now in this case, we already know the x1, that's going to be 2. So x2 is going to equal to our x1, which is 2, minus f of x1, f of 2, over f prime of 2. So let's simplify this. So our f of 2 is going to be 1 over our f prime of 2 is going to be 7. And simplifying this is going to give us 13 over 7. And that's not the best number, and to be honest, that's kind of the ugliness of Newton's method, and maybe that's why some people don't like it that much. But now that we have x of 2, let me go ahead and erase this, and then let me go ahead and just do one more step, and let's see if we can get close to the value that we know the answer is, which is 1. So now we need to find our x3, which is defined by x2 minus f of x2 over f prime of x2. So we're just repeating this process over and over again. So x3 is equal to 13 over 7 minus f of 13 over 7 over f prime of 13 over 7. You can already tell this is going to get pretty messy. All right, doing my math, I get a value of 1.839. So at this point, not the best estimate, but we're slowly getting to the value of 1. And I mean slowly. I have a feeling that if we do x to the 4th, it's probably going to be even closer. And if we do x to the 5th, so we're going to have to do a couple of these estimates. And that's kind of, the con of this whole method. So maybe starting from 1.5 would have been a better choice, because I'm barely at 1.8, so maybe 1.5 would have been a lot better. So as you can see, you're going to learn that for Newton's method, you want to get as close to what you think the root is going to be as possible. But anyway, I hope that you got a sense of what Newton's method does and how powerful it can be. I'll see you in the next one.